بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Here we have an exercise about section 5.1, the area problem. Question 5, estimate the area under the graph of f of x equals 1 plus x squared from negative 1 to 2 using three rectangles and right end points. Then improve your estimate by using 6 rectangles. Sketch the curve and the approximating rectangles. This is the graph of a parabola x squared plus 1, so the parabola will go 1 unit up. So if you replace x by 0, you will have 1, okay? And if you put x1, you will have 2. And the graph would be like this, okay? At negative 1, it is also 2. So he needs from negative 1 to 2, so negative 1, 0, 1, and 2. At 2, it is 5. At 2, it should be 5. So this is 2, 3, 4. Let us say 5 here. Okay. So he needs the area of this region between negative 1 and 2. This is the function y equals x squared plus 1. Now, how we need to estimate the area, okay, using 3 rectangles. So 3 rectangles, what would be delta x? From the formula, it is b minus a over n. B here is 2, a is negative 1, and the number of rectangles is 3. So 2 plus 1, 3 over 3, 1. So just 1, okay? So if you start from negative 1, adding 1, you get 0. So in fact, these are the 3 rectangles. 1, 2, 3, okay? Using the right end points, so this would be first rectangle using the right end points. The right end point here, so this would be the second rectangle. And here from negative 1 to 0, this is the right end point. Okay, so this is the first rectangle, this is the second rectangle, and this is the third rectangle. We have 3 rectangles. All right, so how to find R3? R3, which is the area, the sum of the area of the 3 rectangles. Well, each rectangle, the area is the width times the length. The width is 1, so you can write 1 as a common factor. And we need the length of the first rectangle. The length of the first rectangle is f of 0. This is 0. Okay, f of 0. This distance, f of 0. And the length of the second rectangle is f of 1, this one, okay, this one, f of 1. And f of 2 is the length of the last rectangle. This is the length of the last rectangle, the third rectangle. Now, f of 0, you use this definition. So what is f of 0? 0 squared plus 1, it is 1. F of 1, 1 plus 1, 2. F of 2, 4 plus 1, 5. So R3 is 8. So this is the area. Uh, this is an estimation of the area using three rectangles and the right end points. Improve your estimate by using six rectangles. Well, if we use six rectangles, then delta x would be 2 minus 1, b minus a, but this time over 6. So it's 3 over 6, which is half. So in this time, we will have the following. If we need to graph, this is 0, 1. Let us say this is negative 1 and 2. This is 1 and 2. And here we have 2 and 5. So this is the graph again of the parabola. It continues. We have this line and this line, but now the width is half. So I start from negative 1, add half, I get negative half. So this is negative half. This is the first strip. And then if you add another half, you get 0. If you add half, you get half. If you add half, you have 1, and here 1.5 or 3.2, and then 2. So you have from negative 1 to 2, and you add half the width. So you reach negative half, then 0, then half, then 1, then 1.5, and then 2. Okay, so these are the sub-intervals. So this is now using the right endpoint. So I can use another color. So this would be the first rectangle. This would be the second rectangle. And uh, this rectangle, this one, okay, using the right endpoint. So this would be the third rectangle. This is the fourth rectangle. This is the fifth rectangle. And this one is the last rectangle, the sixth rectangle. We have six rectangles, okay? And again, we need to find this time R6. R6 is the area of the six rectangles. Now the width here is half. You can take it always as a common factor because the width of all rectangles, all the six rectangles, is half. Now what is the length of the first rectangle? This one. It is f of negative half. Okay, f of negative half, the end point, the right end point, plus f of 0 plus f of half plus f of 1 plus f of 3 over 2 plus f of 2. 2, 4, 6, 6 rectangles. And now you use the definition that f of x is x squared plus 1, and you find f of negative half, f of 0, and all of these six values. You add them, you multiply by half, and you find the answer. Okay. Uh, if you want, I can give you the answer. The answer would be 6.875. So please try to do it and make sure that this is the correct answer. Okay. Now, in part B, he says, repeat part A using left endpoints. So we will do the same, but using left endpoints. I will do 3. Let us start by doing 3 rectangles. Again, we have the same function. We're starting from negative 1, 0, 1, and 2. At 0, it is 1. At negative 1, it is 2. At 1, it is 2. And at 2 is 5. That's the graph of the parabola. Okay. And we have these three strips if we are going to use uh, three rectangles. Delta x is not going to change. It is 1 in this case, 2 plus 1 over 3. So it's still 1. But now uh, I will have L3, not R3, because I will use the left end points to construct the rectangle. So the first rectangle would be this one. The second rectangle would be this one. And the third rectangle would be this one. Okay, so we are using the left end points. So what would be L of 3? Again, I can take the one which is the width as a common factor. And now the height or the length is not f of 0. The length of the first rectangle is this line, which is f of negative 1. And the length of the second rectangle is f of 0. And the length of third rectangle is f of 1. And you use the definition. Let us use it. Let us do it here. F of x is x squared plus 1. So f of negative 1 is 2, f of 0 is 1, f of 1 is 2. So L3 is just 5. Okay, you can do the same and find L of 6, L6. In this case, delta x again is half. It's not going to change because 2 plus 1 over 6, because we will use 6 rectangles. But uh, we have from negative 1 to 2, we add half, negative half, 0, half, 1, 3 over 2, 2. This time, the height, the width is half. The height of the first rectangle would be f of negative 1, not f of negative half, plus f of negative half plus f of 0 plus f of half plus f of 1 plus f of 3 over 2. And these are the 6 rectangles. You use the definition of the function, find the values, and try to get the answer here. And I can also help you with the answer. It would be 5.375 if you evaluate correctly. So this is the left endpoint method. The last part of this question, using the midpoint. Okay, so let us use the midpoint. Again, I will sketch the graph. We have negative 0, 1, negative 1, it is 2, at 1, it is 2, at 2, it is 5. So I have this line, okay, and this one, and this one. Again, delta x is 1 because we are going to use 3 rectangles. But now we will use the midpoint, okay? The midpoint means this number. So I need to find this number, okay? I have negative 1, 0, 1, and 2. This is negative 1, 0, 1, and 2. And I need to find the number in the middle, okay? This number, the number in the middle, this one, and this one, and this one. So what is the number in the middle between negative 1 and 0? You can figure out that it is negative half. And if you want, You can always add the two numbers and divide by 2 to find the average. The average is in the middle, which is negative half. Between 0 and 1, 0 plus 1 over 2 is half. 1 plus 2, 3 over 2 is 3 over 2. So these are the midpoints. Now you do what? You from negative half you go up and you sketch the first rectangle. From half you go up and you sketch the second rectangle. From 3 over 2 you go up and then you sketch the third rectangle. So the height of the rectangle would be f of the number in the middle. So to find M3 in this case, we call it M3. Well, the width is always 1, but the height is changing. So what is changing really between midpoint, right endpoint, left endpoint is the height, is the length of the rectangle. So here it is f of what? Of negative half. This is the height of the first rectangle plus f of half plus f of 3 over 2. That's the length of the third rectangle. You can use again the function. The function is x square plus 1. So negative half square is 1 over 4 plus 1. That's 5 over 4. F of half, that's also 5 over 4. F of 3 over 2, 9 over 4 plus 1. So it's 13 over 4. And the answer would be 23 over 4. Okay. So 23 over 4 is the area, the estimated area using 3 rectangles and the midpoint. You can do the same for this for 6 rectangles. If we are going to use 6 rectangles, then we have from negative 1 to 2, this is A and this is B, and delta x, the width would be half as usual, 2 plus 1 over 6, so half. And now you add half, so you get negative half plus half, that's 0, plus half, plus half, plus half, and plus half, that's 2. Okay. And now I need the midpoints. So I need this one, this one, this one, this one, this one, and this one. Because the f of each of these midpoints would be the length of the rectangle. So what is the midpoint here between these two? Find the average. Negative 1 plus negative half over 2. Okay, so this is negative 3 over 2 over 2. It would be negative 3 over 4. You can do the same, negative half plus 0 over 2, which is negative 4, 0 plus half over 2, which is 4, or you can just add half because the distance between each two midpoints is half. So 4 plus half, 3 over 4 plus half, 5 over 4 plus half, 7 over 4. So you can write now M6. The width is half, and the length of the first rectangle is f of negative 3 over 4 plus f of negative 1 over 4 plus f of 1 over 4 plus f of 3 over 4 plus f of 5 over 4 plus f of 7 over 4, and you have 6 rectangles. You use the definition of x to find each one of them, and you calculate them, and you find that the answer is 5.9375. Make sure that this is the correct answer. That's the end of the section. And the best estimate, he may ask which estimate appears to be the most accurate. I believe that M6 is uh, would be the most accurate to this area. Thank you very much, and see you in another video.